Hello, Matthews Gatos here. Welcome to Chapter 7, Rationals, Lesson number 1. In this lesson, we're going to look at rational expressions, in particular how to factor and how to find the non-permissible values. So let's get started. First of all, let's talk about what a rational expression is. So a rational number, first of all, is a ratio or quotient of two integers. So here's some examples of rational numbers. A half, -5/3, 10/15. Those are all examples of rational numbers. Well, in fact, rational numbers are any whole number, natural number, or integer, because I can just put those over 1. Obviously, any fraction, but also any terminating or repeating decimal. Those are all rational numbers. Now, when we look at variables, we can look at the ratio or quotient of two polynomials, and that's called a rational expression. And these rational expressions are what we're going to study in the first 7 lessons of this chapter. Now, we need to review how to factor. Factoring is going to be a really key concept in this unit. And the 2 types of factoring that we're going to do in 30-2 are greatest common factor and difference of squares. So it's really worthwhile reviewing those methods. So this isn't in your workbook, but definitely worth jotting down. For example, if I wanted to find the greatest common factor of 24x squared and 36x squared y, the first thing I need to do is find the greatest common factor of the numbers. So I'm trying to find something that is common to both the terms. So if I look at just the numbers, I want to know what is the biggest number that goes into 24 and 36. Now, if you already know that number, you're ahead of the game. That's great. But I want to show you a little trick on your graphing calculator to help you find the GCF of these 2 numbers. So you can see I have the steps here, but I just want to show you how on your calculator to find that. So first of all, the calculator can help you find the greatest common factor of any 2 positive numbers. So even if one of those numbers is negative, we're going to enter it in as a positive. So on my calculator, here's what I'm going to do. I'm going to go to my math button right here, toggle over to number, and see at the bottom of the list it says GCD. That's greatest common denominator, but that's what we're going to use for greatest common factor. And then we're going to put our numbers in. So we wanted to know the greatest common factor of 24 and 36. So on my calculator, I'm going to go 24, the comma, which is right above the number 7, 36, close off my brackets, and press enter, and there it is. It's 12. Okay, so if you already know it was 12, great, but if you need a little help in that direction, now we know the greatest common factor of those numbers is 12. The second part of greatest common factor is the variables. So greatest common factor is actually the smallest exponent, because it has to be a factor of both, of any variable that is common. So if you look at our variables, x cubed and x squared y, they only have x in common, and I go to the smaller of the 2, which is x squared. So putting it all together, the 12 and the x squared, the GCF is 12x squared. The second type of factoring that you guys have to do is difference of squares. Now, difference of squares is exactly what it sounds. Difference means that the terms are subtracted. Really important, there is no sum of squares. So if those numbers are added, you can't use this. Difference has to be subtracted. And then the other thing is what squares are. And by squares, I mean perfect squares. Well, how do you recognize if a number is a perfect square or not? So let's talk about numbers first. If I take the square root of the number and I get a whole number, or I'm going to add to that, I get a terminating decimal, then I know that I have a perfect square. I'll show you an example of those. Okay, so let's look at things that are perfect squares. Okay, so if I, for example, take the square root of 144. See how I get a nice whole number? That tells me that 144 is a perfect square. It also works for decimals. Let's say I take the square root of 0.25 and see how I get just 0.5. That tells me that 0.25, that's a perfect square. So let's go back and talk about what a non-perfect square is. So a non-perfect square is the square root, when you take the square of a number, it is a non-ending, non-repeating decimal number. And these numbers here are actually called irrational numbers. That's what an irrational number is. So if I take the square root of something and it's a non-ending, non-repeating decimal, then it is not a perfect square. Let me show you an example. So if I go back to my calculator, let's try the square root of 26. So see how I have this non-repeating, it kind of looks like it ends, but it doesn't. I assure you it goes on forever and ever and ever without any repeat. The calculator is just showing us the first 10 or so digits after the decimal. So that would tell me 26, not a perfect square. Same thing with decimals. Let's say I did the square root of 0.5. See how that's non-repeating? It doesn't have like 7, 7, 7, 7, 7. There's no pattern. So this tells me that 0.5 is not a perfect square. Okay, so now that we know how to recognize perfect and non-perfect squares in numbers, let's look in variables. So when I take the square root of something, it's like raising it to the exponent of a half. So when I take the square root of something, that's like going x to the 1/2. Raising the number or the root to the 1/2. So since that's the case, the square root of a variable is whatever your number is divided by 2. So perfect square variables are variables where the exponent is even. Non-perfect square variables, the variable has an exponent that is odd. Okay, so factoring a difference of squares. First thing again, I can't emphasize this enough, it has to be a difference of squares. So it has to be subtracted. Here's how we're going to factor it. We're going to take the square root of each term. We're going to place the square root of the first term as the first term in each factor, the square root of the second term as the second term in each factor. Separate the terms by plus, minus in any order, meaning I could do plus minus or minus plus. So here's an example. If I have a squared minus b squared and I want to factor that, the square root of a squared is a. It goes as the first number in each bracket. The square root of the second term, b squared, is b because half of 2 is 1. And it goes as the second term in each one. And then I just add a term and subtract a term or subtract add. Either is fine. So this is correct, or I can do plus minus. Either is good. Okay, so now that you know the two ways that we're going to factor, let's practice. So I want to write the following expressions in factored form. The very first thing that I look for in every question that I do is there a GCF? So I want to look for, is there a GCF? So looking at 8 and 24, notice it was a negative. I still did it as a positive. The greatest common factor between 8 and 24 is 8. So what I'm going to do is I'm going to write my greatest common factor outside the brackets, and inside the brackets, I am going to divide each term by 8. So 8 divided by 8 is 1. I'm left with x. Minus 24 divided by 8 is 3. And then I'm done. Okay, look at this one here. 10x cubed and 2x. So GCF between 10 and 2 is just 2. So I'm going to use that. So I know my greatest common factor has a 2, but look, they both have x's. Okay, one of them is x cubed, the other is x to the invisible 1. So the greatest common factor is the variable with the smaller exponent. So I'm going to take a 2x to the 1. So I write the GCF on the outside. So just like here, this is the GCF. I write the GCF on the outside. And then on the inside, I divide each of the terms by the GCF, which is 2x. So 10 divided by 2 is 5. X cubed divided by x. Well, there's 3 on top, 1 on bottom. 3 take away 1 is 2. So it's x squared. Plus 2 divided by 2 is 1. X divided by x is also 1. So this is how it factors. Now you don't necessarily have to write the 1. You can just say it's 2x multiplied by 5x squared plus 1. And then that would be your final answer. Okay, let's try this next one. So x squared minus 16. So the first thing I notice is there's a 1 in front of the x squared. If one of the coefficients has a 1 in front, there can't be a greatest common factor other than 1. Okay, so I'm done. I don't have any greatest common factor. I look and I see that the two terms are subtracted. So I am suspicious that its greatest common factor, other than 1, is that this can be factored using a difference of squares. So I know that the square root of x squared is half of my exponent, 1. And I know the square root of 16 is 4. So I'm going to put that together and factor. So square root of x squared is x. It goes as the first number because it was the first number in the question. 16, the square root of 16 is 4. It goes as the second term. And then you add one set and subtract the other, or vice versa. And that's how it factors. Okay, let's look at this next one. So both of these have a 1, so there is no greatest common factor for numbers. However, both of them are x. So this is x to the 3, this is x to the 1. The greatest common factor is the smaller of the two, which is just x to the 1. So I'm going to divide each of these by 1. So x cubed divided by x. There's 3 on top, so there's more on top. 3 take away 1, 2. So x squared. Minus x divided by x is 1. Now, it looks like we might be done because we've done the GCF, but you always check what's on the inside to see, can that go further? And I see that that's a difference of squares because I know the square root of x squared is half of the exponent, and I know the square root of 1 is 1. So these are, again, a difference of squares. So don't forget about your GCF of x. Keep that out there. And then I'll do square root of x squared is x, square root of 1 is 1, add one set, subtract the other, doesn't matter the order. And now it's factored. So always start with greatest common factor and then check for difference of squares. Now, I'm a big fan of the check on the graphing calculator. So if I ever want to check to see how something factors, let's say I factored it like this and my friend factored it like this, and I want to know who is right. Well, you can use your graphing calculator to help you. So in the y equals part of your calculator, you put the original question, which is 8x minus 24, in y1. Then you put the two ones that you're trying to check to see which one's right in y2 and y3. The check always happens in the table. And I can see in the table that y1 equals y2, so I know that the first one is right. So since y1 equals y2, I know that 8x minus 24 is equal to 8 times x minus 3. So you can always check your factoring in the table, and just remember that the check always happens in the table. Okay. Let's talk about non-permissible values. So when we talk about dividing, it is really important that we talk about non-permissible values because this rational expression, 6 over x, this is 6 divided by a number. So the variable x is any number. So what happens when the expression is, when x is 2? Instead of having 6 divided by x, I have 6 divided by 2, which is 3. That's okay. But what happens when x is 0? I would have x equal to 0, so 6 divided by 0 is, and if you do that on your calculator like I showed you, an error message. You cannot divide by 0. Let's talk to you about why. So I wonder if you guys know why you can't divide by 0. Well, I'm going to take you back to the one that I could do. So I can do 6 divided by 2 equals 3. That's no problem. And the reason that this works is because 3 times 2 equals 6. So if I go to 6 divided by 0, if you think about that, if it were equal to a number, we know it's an error, but let's say it equals a number, just like over there, then that means that some number multiplied by 0 equals 6. And hopefully you can see that's impossible, because if I multiply 0 by any number, this is not going to ever equal a number. It will only equal 0. So the reason we can't divide by 0 is because there is no number I can multiply 0 by to get something other than 0. So we have to pay attention to that when we're doing division, to the non-permissible values. Okay, here's an example of all of these rational expressions. Let's look when they're not defined. So 6 divided by x. I put this into my graphing calculator to help me. And 6 divided by x has an error when x is 0. So that means my non-permissible value, the value that x can't be, is 0. Let's look at this one, 10x over x plus 3. So you can see I have an error here when x is negative 3. So that tells me that the non-permissible value is negative 3. I can't be negative 3. Looking at this next one, 8 over x minus 1 and x minus 2, you can see when x is equal to 1, I have an error, and when x is equal to negative 2, I have an error. So I have two non-permissible values. My non-permissible values are at negative 2 and 1. This is different than the other ones. The reason is that the number of factors you have is equal to the number of non-permissible values. So look, I just had one value of x, one non-permissible value. One factor, one non-permissible value. Here I have two factors, so I have two non-permissible values. Let's look over here, two factors. So again, I should expect to see two non-permissible values. And we see one here at 0, so I have a non-permissible value at 0, and another one at 2. So a non-permissible value at 0 and also at 2. So filling this in, these are the non-permissible values that we just stated, 0, negative 3, negative 2, 1, and 0 and 2. So the number of factors is equal to the number of non-permissible values. Non-permissible values are in the denominator only. You can't divide by 0. The other way around is okay. You can do 0 divided by a number, but you can't do it the other way around. So let's look at this, and we're going to make a connection between the rational expression and the values of the variable. So the connection between those two is whatever value of x makes the denominator equal to 0, because I can't divide by 0, is the non-permissible value of x. So let's try this. So state the value of the variables for which the following rational expressions are not defined, sorry. So x minus 6, what value of x can I put in there that you would cause yourself to divide by 0? Well, that would be 6, because 6 take away 6 is 0. So since 6 take away 6 is 0, my non-permissible value is 6. If you look here, I have two factors. So let's look at my first one, x plus 5. Well, that non-permissible value is negative 5. So I just did the opposite, because negative 5 and positive 5 is 0. So see here how I had a minus 6 and my non-permissible value is a positive. Here I have a positive 5. My non-permissible value is a negative 5. Well, look at this one. I have a negative 9. So the non-permissible value following that pattern should be positive 9, because 9 take away 9 is 0. Okay, so these are how I can figure out the non-permissible values. So values of the variable that result in the rational expression being divided by 0, not being defined, are called non-permissible values. Okay, so for example here, let's look at this one here. Non-permissible value, the opposite of a positive 5 is a negative 5. And the opposite of a negative 9 is a positive 9. So those are my non-permissible values. Now, closely tied to non-permissible values are restrictions. Okay, and restrictions are just written as x cannot equal to the non-permissible values. So the non-permissible values are what the variable can't be, and the restriction is stating that. So for example here, if you look at x minus 6, I know the non-permissible value is 6. So the restriction is x cannot equal to 6, which is the non-permissible value. So restrictions are x cannot equal to the non-permissible value. That's how you write a restriction. So for example here, I have x plus 5. So the non-permissible values are that x cannot equal to negative 5. And here, the opposite of a minus 9 is a plus 9. X can't equal positive 9. Or we can put them together like that. X cannot equal to negative 5 and 9. So again, restrictions are x cannot equal to the non-permissible value. Okay, so just a little note here. Non-permissible values are found by determining what makes the denominator equal to 0. So fractions, anytime you have a fraction, that means division. You can't divide by 0. You can do 0 divided by anything and get 0, but anything divided by 0 is an error. So the way that I remember that is this. Okay, it is okay to have a 0 in the numerator, but it is a big no to have 0 in the denominator. Okay, so let's look at this one here. I want to determine the non-permissible values of the rational expression. Well, before I can do that, I'm going to take this and I am going to factor it. So I have 5x squared minus 5x. Now looking, I have a 5 and a 5, so my GCF for sure is 5. And then I have x squared and x. So I have x in common, and I go to the smaller of the two, which is the 1. So GCF on the outside, and then I just divide each term by the greatest common factor. So I'll divide 5x squared by 5x, I'll divide 5x by 5x, and put the result in the bracket. So 5 divided by 5 is 1. X squared divided by x, I have 2 on top, 1 on bottom. 2 take away 1 is 1. Take away 5 divided by 5 is 1. X divided by x is also 1. So I can just write this as x minus 1. I don't really need to put the 1 in front. So to find the non-permissible values, what I'm going to do is I'm going to set each of these to 0 because that's what x is not allowed to be. It's not allowed to be 0. So let's look at what value would make it 0. So divide both sides by 5 and I get that x equals to 0, and add 1 to both sides and I get x equal to 1. So what that tells me is that my non-permissible values are 0 and 1. In other words, in this expression here, if I were to put in a 0 here and here, I would get a denominator of 0, and I can't divide by 0. Similarly, if I put the 1 in there, I would also get a denominator of 0, and I can't divide by 0. So those would be my non-permissible values. Now, as a little shortcut, I can also do these on the calculator, because if I'm looking for what value of x makes the denominator 0, that's really just an x-intercept. So the x-intercepts of the denominator are the non-permissible values of the entire fraction. So if I ever want to do that, I can put my denominator into y1, put in 0 to y2, because I want to know what value of x makes that denominator 0, and find the intersection. And you can see I get 0 and I also get 1. So you can do it by factoring, or you can use your graphing calculator to find your non-permissible values. Either way is fine. Okay, so let's look at these ones here. So to determine the non-permissible values. So I'll do it algebraically, but I'll also show you what the graph looks like. So the non-permissible values would be whatever makes 2x minus 4 equal to 0. So I will add 4 to both sides, divide both sides by -2, and it looks like my non-permissible value is -2. Let's check that on our graph. So on our graphing calculator, I put my entire denominator into y1, and I put 0 into y2, and you can see that it intersects at -2. So you guys have a choice which way you want to do it. Just remember, you're only doing it for the denominator because it's a no to have 0 in the denominator, but it's okay to have 0 in the numerator. Okay, let's look at our next one. In this next one, I want to find out what the value of p is that makes my denominator 0. So looking at this, I have a greatest common factor of p. So I'm going to factor that out first. So remember, when you're factoring it out, you write your GCF on the outside, and then you just divide each of your terms by the GCF. So 4 divided by imaginary 1 is 4. P squared divided by p, there's 2 on top, 1 on bottom. 2 take away 1 is 1. Take away p divided by p is 1, equal to 0. So I set each factor to 0. So p can equal 0, or 4p minus 1 can equal 0. So here I would add 1 to both sides and divide both sides by 4. So my non-permissible values are 0 and 1/4. Or if you like, you can put that into your graphing calculator. So you can see I put my entire denominator into y1. I put 0 into y2, and you can see I found out the x-intercepts at 0 and 1/4. So either way that you want to do it is fine by me. Let's try some other ones. So a squared minus 49. There's a 1 in front, so I know there's no GCF. So I can take the square root of my first term and the square root of my second term, and I see that since they are both perfect squares, this is a difference of squares. So a squared minus 49, I want to know what value of a makes that 0. So I factor, and then I set each factor to 0. So a minus 7 could be 0, or a plus 7 could be 0. So remember, it's just opposites. The opposite of a minus 7 is a plus 7. The opposite of a plus 7 is a negative 7. So it looks like my non-permissible values are positive and negative 7. Again, I can check that in my calculator. So you see there's my entire denominator in y1, 0 in y2, and I get the same non-permissible values, negative 7 and positive 7. Okay, in my next one. So again, I cannot divide by 0. So whatever 2x squared plus 8 is, it has to equal 0. So algebraically, if I were to solve that, I would subtract 8 from both sides and then divide both sides by 2. Now, look what I get. I get that x squared is equal to negative 4. It is not possible to square a number, which means multiply it by itself, and have it equal to a negative. If you don't see it at this step, watch here. If you take the square root, can you take the square root of a negative 4? You can't do that. So I know that there would be no way that this thing is ever going to equal to 0, which tells me that means there are no non-permissible values. So we can even check this on the calculator by putting the entire denominator into y1. So you can see I did that here, and you can see it doesn't ever cross this x-axis. So there's no chance this is ever going to be 0. So that means there is no non-permissible value for the second one. Okay, so let's try a little twist here. This time we're going to write a rational expression, and they're going to give us some rules. So I want to write a rational expression where it has a variable of x and a non-permissible value of 3. So there are many answers to this. I'm just going to go with the most basic one. So I have to have a variable of x, and I have to have a non-permissible value of 3. So one non-permissible value means one factor in the denominator. So if my non-permissible value is 3, my factor is the opposite of that, which is x minus 3. And then I can put anything in the numerator, such as my favorite number. So that would be a rational expression with a non-permissible value of 3. Okay, in this one here, I want to do the variables a, and I have 2 non-permissible values. So 2 non-permissible values just means 2 factors. So if I have a non-permissible value of 0, that means my factor is just the monomial x. If I have a non-permissible value of 4, that means that my factor in the denominator is the opposite, which would be minus 4. Oh, we were supposed to use a's. My mistake here. So I should not use x's. I need to use a's. There we go. And I can have anything I want in the numerator. Let's say we have an a squared, for example. So that would be a rational expression, variable a, with non-permissible values of 0 and 4. Okay, in this one here, I have a variable of p and a non-permissible value of 1 over 3. So a non-permissible value, one non-permissible value means I have one factor in the denominator. So let's look at our non-permissible value. Our non-permissible value is a fraction, and factors can't have fractions in the denominator. So what I'm going to do, since my non-permissible value is 3, I'm going to set p equal to a third. That's my non-permissible value. I want to find a factor. So what I'm going to do is multiply both sides by 3 to eliminate the fraction. So what I'm doing here, guys, is I'm trying to find a fraction, or a factor, sorry, that has this as the non-permissible value. Because I can't have p minus a third. I can't have that as a factor because I'm not allowed fractions. Okay, and then I'll subtract 1 from both sides. And this is my factor, 3p minus 1. Now the opposite rule still works. Watch. Positive 1, the opposite is negative 1. Divide by 3, the opposite is multiply by 3. So there is my factor in the denominator, 3p minus 1. And then that's all it said. You can have anything in the numerator. For example, let's have -4. So that would be a rational expression that satisfies all of those conditions. But again, remember, you cannot have a fraction in your a fraction in the denominator. No fractions over fractions. So to summarize my lesson, restrictions are the values that x cannot equal. The non-permissible value is just those values of x by themselves. So the degree is the maximum number of solutions and the maximum number of restrictions. Monomials at degree 1 always have the restriction variable can't equal to 0. When you're factoring, I always want you to look for your greatest common factor first and the difference of squares second. The most important thing with fractions is your non-permissible values, because friends don't let friends divide by 0. So I hope that this lesson helped. You guys can go on to do your assignment, which is number 1 to 8, and I'll see you for the next video.